Okay, let us now discuss question number 6. We have discussed up to question number 3 and question number 4 and 5 are very easy. So, I am skipping those two questions. We will going to discuss question 6 directly, and from question 6 I will discuss only these parts, okay, these subparts. So, question 6 says, which of the following are APs? If they form an AP, find the common difference D and write 3 more terms. Okay. So, there are some sequence given and we have done this kind of question in this kind of exercise in question number 2 also. So, this question number 6 has some special cases. These are some special cases in which you may face problem. If you solve them, it's very good. If you can't, just observe what I am doing. Okay, I will solve them on board. So, let us discuss the fifth part of question number 6. The fifth part of question number 6 is the sequence given in fifth part. The list is 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2 and so on. Now, I want to check whether this is an arithmetic progression or not. What I am going to do is simply you can write second term minus first term, second term minus first term, then third term minus second term, then fourth term minus third term. Okay. So, second term minus first term, second term is 3 plus root 2 and minus 3, then third term is 3 plus 2 root 2 minus 3 plus root 2, then fourth term is 3 plus 3 root 2 minus 3 plus 2 root 2. So, second term minus first term, it will give you root 2. Then third term minus second term, this will again give you 3 and 3 will get cancelled, and 2 root 2 minus root 2 will give you root 2 again. So, this is root 2, this is root 2. Then let us check this case also. 3 and 3 will get cancelled and you will have 3 root 2 minus 2 root 2. So, this will give you root 2 again. So, what you can see, the common difference in this arithmetic progression is root 2. So, what will be the next two terms? We need to determine next 3 terms. Okay. So, it is very easy to determine next 3 terms. I am going to determine only one term and the rest 2 you can determine it very easily. So, this is the fourth term. If I want to determine fifth term, I will simply add root 2 to this this fourth term and it will become 3 plus 4 root 2. Okay. And you can determine the successive terms after this. So, this is definitely an arithmetic progression, because you can see that the common difference is an irrational number while the first term is a rational number. So, you may get confused here, that is why I have discussed this part. So, this is the fifth part. Let us discuss the sixth part. The sixth part of question number 6. Question number 6, sixth part. Sixth part is, let us write the sequence. It is 0.2, 0.22, 0.222, 0.222 and one more 2 and so on. Okay. Now, let us check whether this is an arithmetic progression or not. What I am going to do is second term minus first term. So, 0.22 minus 0.2, how much it will be? 0.22 minus 0.2, it will give you, this is 0.2 will get cancelled, it will give you 0.02. Then third term minus second term, third term is 0.222 minus second term is 0.2 and 2. So, when you subtract these two values, what you will get? You will get 0.002. Now, you can see the difference between first two terms is 0.02 and difference between the third and the second term, that is the next two terms, is 0.002. So, can you see a similarity? Are these two values similar? Are these two values equal? No. it means there is no common difference. The difference between consecutive terms is not constant, that is, there is no common difference, hence this is definitely not an arithmetic progression. Do I need to check further? No. From this I can say that this is not an arithmetic progression. Okay. So this is the sixth part of question number 6. Then let us discuss, this is 5th, 6th, 7th. This is the 7th part of question number 6. 7th part of question number 6. So question number 6, 7th part, the sequence given is 0, -4, -8, -12. Now let us check whether this is an arithmetic progression or not. Second term minus first term, second term is -4 and first term is 0. So -4 minus 0 is -4. Then third term minus second term, third term is -8, then second term is -4. So -8 minus of -4, it means -8 plus 4. So this will give you again -4 only. Then -12, that is fourth term minus third term, -8. So -12 plus 8 will give you -4. So what you can see, that the difference between two consecutive terms is constant, it means definitely this is an arithmetic progression. And what will be the next term? You can simply add common difference, that is -4 to this term. So -4 minus 12 will give you -16. This is the next term. So this is the 7th part. 8th part is, so let us solve this part here. Question number 6, 8th part. The series given is -1/2, -1/2, -1/2, -1/2 and so on. Okay, this is the series given. So let us check whether this is an arithmetic progression or not. First we will do second term minus first term. Second term is -1/2, first term is again -1/2. So -1/2 minus of -1/2, that is +1/2. So -1/2 plus 1/2 मतलब 0. फिर third term minus second term, -1/2 minus of -1/2, it will become 0. Then fourth term minus third term, fourth term is 1/2 minus third term is -1/2, मतलब ये भी कितना होगा 0. So what you can see, that the difference between any two consecutive terms is a constant value, that is 0. So this is definitely an arithmetic progression. Now you may feel that this common difference is 0. So this is a constant, every term is -1/2, -1/2. But remember, arithmetic progression is what? It is a series of numbers, it's an arrangement of numbers in which there is a fixed number which is added to each term to get the next term. So if I add 0, then 0 is also a number. So it's very comfortable to take 0 as a common difference also, because it is possible that an arithmetic progression may have a 0 as common difference. So what will be the next term? Next term will be simply -1/2 only, because you have added 0 to this term, and to get next two terms also again add 0, that is you will get -1/2 and -1/2. Okay. So this is the 8th part. Then let us discuss the 9th part of this question. Question number 6, 9th part, sorry 9th now, this is 11th part discuss करते हैं. Question number 6, 11th part. The list of numbers is a square, a to the power 3, a to the power 4 and so on. So whether this is an AP or not, let us check it. Second term minus first term, a square minus a, it means this is a minus 1. Okay. Then third term minus second term, third term is a cube minus second term is a square, it means it is a square times a minus 1. Now can you say that this एंड दिस आर इक्वल। क्या आप कह सकते हैं कि ये दोनों इक्वल हैं, a टाइम्स a माइनस वन और a स्क्वायर टाइम्स a माइनस वन? क्या ये दोनों वैल्यूज इक्वल दिखाई दे रही हैं? नो, these two values are not equal, hence I will say this is definitely not an arithmetic progression. This can be an arithmetic progression only if a is equal to 0 or 1. okay, अगर a का वैल्यू 0 रखूंगा तो a will be 0, a square 0, a cube 0, a to the power 4 0, and all the terms will be 0. okay, so it can become an arithmetic progression. और अगर मैं a का वैल्यू 1 रखूंगा, then also this will be 1, this will be 1, 1, 1 and so on. So all the terms of this arithmetic progression will become 1. okay, in only these two cases, if a is equal to 0 or if a is equals to 1, then only I can say that this will become an arithmetic progression. Otherwise this is not an arithmetic progression because the difference between two consecutive terms is not constant. okay, so this is the 11th part. Let us discuss the 12th part. The 12th part is question number 6. The 12th part of this question is, it is root 2 comma root 8 comma root 18 comma root 32 and so on. okay, this is the sequence, this is the sequence given. Now I want to check that whether this is an arithmetic progression or not. What I will do, I will simply subtract second term and first term. Second term is root 8 minus first term is root 2. So now what is root 8? Root 8 is 2 root 2 because root 8 is equal to root of 2 into 2 into 2. So you can take one pair of 2 as common and it will come out of the root and it will become 2 root 2. okay, so root 8 minus root 2 will be 2 root 2 minus root 2. okay, so 2 root 2 minus root 2 is root 2. Now after that, third term minus second term. Third term is root 18 minus second term is root 8. Now what is root 18? How will you calculate root 18? Root 18, square root of 18 will be equals to square root of 3 into 3 into 2. So you can see this 3 and 3 will form a pair and 1 3 will come out of the root and this will become 3 root 2. So in place of root 18 I can write 3 root 2 minus, in place of root 8 I can write 2 root 2. So 3 root 2 minus 2 root 2, it will give you root 2. okay, now after this, now you can see that the difference between the first three terms, the consecutive terms, this pair and this pair, it is root 2 and root 2. That's why I want to check this one also. I need to check this one also because if this difference is not equal to root 2, I can say that this is not an arithmetic progression. If this difference become root 2, I can definitely say that yes, this is an arithmetic progression. Now what about root 32? I will have the next value as root 32 minus root 18. What is root 32? How will you calculate root 32? Root 32 can be written as root of 16 into 2. That is 16 is what? 16 is basically square of 4. So I can write root 32 as 4 root 2. So in place of root 32 I can write 4 root 2 and in place of root 18 it will be 3 root 2. So it will again become root 2. So what you can see, you can very easily see that this is definitely an arithmetic progression because the common difference, the difference between any two consecutive terms is constant, that is equal to root 2. So if this difference is root 2, then what will be the next term after this? What will be the next term? The next term after this we will get by adding root 2 to this root 32. So if you add root 2 to root 32, what is root 32? It is root 32 is basically 4 root 2. if you add root 2, it will become 4 root 2 plus root 2. So it will become 5 root 2. Okay, it will become 5 root 2. So the next term will be 5 root 2, or you can use a simple identity that a root b, okay, try to observe this, a root b is basically equal to root of a square b. This is a very simple identity. This is derived from the chapter of exponents that you have studied in your junior classes. A root b is equals to square root of a square b. Here 5 root 2 can be written as, if I compare this 5 root 2 with a root b, I can write this 5 root 2, I can write this 5 root 2 as root of 5 square into 2. What is 5 square? It will be 25, and into 2 is root of 50. So the next term after this root 32 will be root of 50. Okay, I have applied this condition, this identity, a root b is equals to square root of a square b. Here also I have root 50. Now what will be the next term after root 50? You will add one more root 2. Root 50 is 5 root 2. So the next term will be 6 root 2. Okay, and again 6 root 2 can be written as square root of 6 square into 2, that is 36 into 2, that is 72. So the next term after this will become square root of 72. Why? Because this is 6 root 2. This is 6 root 2. Why you have got 6 root 2? 6 root 2 is because this is 5 root 2 plus root 2, and I have applied this condition. And so on, you can determine different terms, the successive terms of the series. Okay, so this is a very important question. This is a very logical question. Now, so this is question number. So this was question number 12. So we have solved the 12th question. Now let us discuss question number, this is 13th one and 15th one. Okay, so for that I am rubbing this part. So let us discuss the 13th part, question number 6. 13th one. 13th question says it is root 3, comma root 6, comma root 9, comma root 12, and so on. Now whether this is an AP or not, let us check. Second term minus first term, root 6 minus root 3. Okay, so it will be root 6 minus root 3 only. Or what you can do is, you can write it as like this, 3 into 2 minus root 3. Okay, what I have done, I have written this 6 as 3 into 2. So now from this I can write this as root 3 into root 2 minus root 3. I can separate this, and from this I can take root 3 as common, and in bracket you will get root 3 times root 2 minus 1. So this is the difference between second term and first term. Similarly, let us calculate the difference between third term and the second term. Third term is root 9 and second term is root 6. So how will you calculate the difference? This root 9 is this root 9 is 3 minus root 3 into root 2. Okay, square root of 9 is basically 3, and in place of root 6 I have written root 3 into root 3. Now what you can write for this 3? This 3 can be written as root 3 into root 3 minus root 3 into root 2. So from this you can take root 3 as common, and in bracket it will become root 3 minus root 2. So you can see the difference between first two terms is root 3 times root 2 minus 1, and the difference between next two terms is root 3 times root 3 minus root 2. So can you observe the difference between these two values? Root 3 is constant here, but root 2 minus 1 and root 3 minus root 2 are not equal. Okay, that's why I can say this difference and this difference are not same, hence the difference between next term and previous term is not a constant value. Difference between these two terms is this, and between these two terms is this. That's why I can say this arrangement of numbers do not form an arithmetic progression. This is definitely not an arithmetic progression. Okay, then this is the 13th part. Let us discuss the 15th part of question number 6. Question number 6, the 15th part. What is the 15th part? It is 1 square, then 5 square, then 7 square, then 73, and so on. So can we check whether this is an AP or not? Very easily we can check it. Second term minus first term. Second term is 5 square minus first term is 1 square. So second term minus first term, that is 25 minus 1 will give you 24. Okay. After that, third term minus second term. Third term is 7 square minus second term is 5 square. So when you subtract 49 and 25, you will again get 24. Okay, this will be the difference of third term and second term. Now, I have checked only up to third term and I have got the difference constant. So do I need to check for the fourth term also? Do I need to confirm that the difference between fourth and third term is also 24? Can I directly say that this is an AP based on the result obtained by subtracting these three terms? क्या मैं ऐसा कह सकता हूँ? No. I cannot confirm that this is an arithmetic progression till I have checked this term also. I need to check up to this fourth term or the number of terms given in the sequence. Then only I can confirm this particular sequence form an arithmetic progression. Okay. So let us check for the fourth term also. Fourth term is 73 minus third term is 7 square. This is 73 minus 49. So what is the difference between 73 and 49? Add 1 to this 49, then add 23, you will get 73. So 1 plus 23, that is 24. So you can see the difference is constant in all the consecutive terms. So this is definitely an arithmetic progression. So what will be the next term after 73? Just add 24. You will get the next term, then again add 24, you will get the next term, and so on. Okay. So in this manner you need to solve question number 6. I have discussed all the important parts of question number 6. Rest of the parts you can solve, and from next class we will discuss new concept, that is the concept of general term of an arithmetic progression. Okay. So you can note this.